Guys, welcome back. Okay, here's an activity. I want us to do it together. There are some questions there. You're given a graph. What is missing is the reaction. Let me write it here at the top. So it's N2 plus H2 to form NH3, ammonia. And delta H is less than 0, right? So you can pause and attempt to answer A, B, and C because that's what we're going to be doing today. So if you look there, I want us to focus on graph analysis, on how to figure out which part is the part that shows which disturbance and so on, right? So let's quickly get into it. We've got a change. Okay, before the change was made, let's start with at T0 to T1, the concentrations are remaining constant, right? What does that mean? They are remaining constant, which means that the reaction is in a state of equilibrium. It's in a state of equilibrium. Then something happens at T1, right? And then again, there's a change after that happens. There's a change in the concentrations. Then something happens at T2. You can see the concentrations are constant again until another dramatic change happens at T3, right? Okay, let's analyze it and answer it and make sure that we understand it going forward. So the changes that can happen, let us all travel to Cape Town. Let's all travel to Cape Town. These are the changes that can happen, right? Or the factors that can disturb the equilibrium, sorry. So these are the factors that can disturb the equilibrium that we're going to deal with, which is concentration, C, pressure, P, and temperature, T, right? Then, what I want us to look at is, how do you know which one happened where? How do you know which one happened where, right? We know that before getting into analyzing it, we know that when there is a change in concentration, there will be a sharp increase or decrease in that specific substance that was either added or removed. So when it comes to a concentration change in the concentration time graph, if there's only one of the concentrations that was changed, either one reactant or one product, there'll be a sharp increase or sharp decrease there, right? And then the rest or the other substances that are also in the reaction will change gradually after the disturbance. Ne? So one spike, it can also be two, and then the others are gradual. That means the change is concentration. Then with pressure, when you decrease the pressure, when you increase the pressure, then all of them, their concentrations change at that instant. Why? Because now they're occupying, if you have increased the pressure, then it means they're now occupying a smaller volume than before, right? So concentration is number of moles per unit volume, so our concentration is going to increase. So all of them will have a spike or a sharp decrease or increase. While when it comes to temperature, there'll be a gradual change in both the reactants and the products, right? So let's take this to this graph that we have here. One spike, so if you look at these disturbances, T1, T3, and T5, these are the disturbances we're going to be focusing on. T1, you see there's a gradual change in all the reactants and the products. So the change or the disturbance that happened there is definitely a temperature disturbance, right? Then T3, there is a sharp increase or rather decrease in all the reactants and in the product, right? So the change that happened here is pressure. Then T5, there's only a sharp increase in the concentration of the N2, which means that is the concentration of N2, right? To be specific, the concentration of N2 was increased, right? While at T1, we can still also figure out whether the temperature was increased or decreased by looking at which is favored. Is it the forward reaction or reverse reaction after the disturbance? Ne? How do we see that? So remember, if the forward reaction is favored, then the concentration of the product is going to increase. Like in this instance, NH3 is a product, and if you look after the disturbance, the NH3 concentration increases, right? Which means it was favored. The forward reaction is exothermic. The reverse reaction is endothermic. So it means we know that it's a decrease in temperature that favors the exothermic reaction. It favors the reaction that releases heat, right, to reinstate equilibrium. So that means decrease in temperature is what must have happened at T1. Then at T3, we know that an increase in pressure favors the reaction with the least number of, producing the least number of gaseous moles, right? So if you look there, you can see that the concentration after the disturbance, the concentration of the reactants N2 as well as H2 increases, which means they are favored. The pressure was decreased and the reaction producing the most number of gaseous moles was favored, which is the reverse reaction. So the reverse reaction, there is how many gaseous moles that are produced there, because all of these are gases, right? All of these are gases. So how many gaseous moles do you have there? You have 1 and 3, so there is 4 in total, while on the product side you only have 2, right? So it means the reaction that produces the least number of gaseous moles will be the forward reaction, while the reaction that produces the most number of gaseous moles will be the reverse reaction, right? So I hope that's going to help you to be able to answer A, B, and C. I've covered all of them. I just haven't given them step by step, right? So that you get an idea. I was using them as a guide to be able to analyze this graph. I hope the video was very helpful to you. Please subscribe and share it with your friends and whoever may find it helpful as well. I will see you on the next video.